All right. In this set of notes, we're going to be talking about segment bisectors. Segment bisectors. And specifically, we're going to ask, how do I solve a problem using segment bisectors and variables. Now, we've already talked about what segment bisectors are in a previous set of notes, so I won't go over that again. So we'll just jump right into our example. Okay. Example, we've got find x. That's what we're supposed to do here. And here is our picture here. We've got A, M, B. Mark these two as the same. We've got 4x plus 2, 8x minus 6. And we're going to just add that M is the segment bisector of AB. Segment bisector of segment AB. That's not really necessary, I guess, since we've already marked the two. You should be able to tell that from the diagram, but, just in case. Over here, our statements and reasons. We'll divide our column down the middle. All right. So first, our very first statement is that AM equals MB, and that is the definition of segment bisector. This is what the bisector does. Two parts are equal. Next, we're going to say that 4x plus 2 equals 8x minus 6. And that's just substitution from the diagram. Little star there. I'll put a little star. That's where they got that information from. Okay, so next, let's see, I want all my variables on one side, so I'm going to take the variables away from this side. I'm going to subtract 4x. So that's going to leave us with a 2 over here. 8x, take away 4x, is 4x minus 6, and that's just the subtraction property. Now, that would be subtraction property of equality, but I'm not going to write it this time just because I've written it so many other times. It should be obvious by now what it's from. Now, see, I want to have all of my constants on one side. I want it to be the other side over here, so I need to get rid of this negative 6 by adding 6. That's just going to leave us with the 4x over here. And 6 plus 2, or 2 plus another 6, is 8. So we've just used the addition property of equality again. And then next, if we have 4x equals 8, we want to just make it a single x. So we have to divide by 4. And so 4x divided by 4 is just x, and 8 divided by 4 is 2. And that's what we were after. And we used the division property Of course, again, of equality, but I'm not really writing that out. So again, now if you were doing this just to get the answer, you wouldn't write all these reasons out, but you want to have a good detailed example to look back on. So starting here, from our diagram, we know that the two sides are equal because this is a bisector, and a bisector cuts the segment into two equal sized pieces. Okay. Then we just substituted from our diagram, our two expressions from the diagram. And then each equation, of course, will end up being different. Here we had to use the subtraction property, the addition property, and the division property to get down to our x equals. But in general, when you've got variables on both sides, you want to get all your variables on one side, which means you have to take the variables away from the other side, or sometimes add variables in, whatever we have to do. This was a positive 4, so we took 4 away. If it had been a negative 4, we would have added 4x. Then we want to get all of our constants on the other side. So if we had this negative 6 here, we had to add 6 to get rid of it. And we wanted the rest of our constants over here. So we had variables on this side, constants on the other. It doesn't really matter which side you pick. I could have done it where I had variables over here, constants over here. That would have been fine. Now, at that point, you've got the term, a single term that has your variable. And we just divide by that coefficient, because I have 4 x's here. I only want one. Single one right there. So I divide by 4. Of course, I have to do the same thing on the other side. That's the division property of equality. End up with 2 equals x. And we're finished.
2 equals x.